Well, good morning, and thank you for attending session F15. My name is Jim D. I work for BMC Software. I'm the moderator for this session. Today we're listening to Jane Mann. She's going to be talking about Db2 for ZOS, JSON enhancements, and use cases with Watson. Jane's a developer on Db2 for IBM. Okay?
Thank you. So before I start, is my voice okay? You hear me well? So anytime, for any reason, if you cannot hear me well, just let me know, raise your hand, or I'm speaking too fast or too slow or too boring for you, okay? So my name is Jane Mann. In case you don't know me, I'm a senior software engineer in Db2 development. So I've been with IBM for about 15 years with more than 10 years in Db2. So my focus area is from XML, JSON. In my spare time, I like to do research on all these modern technologies around Db2, like Spark, machine learning, Node.js, all this stuff. Okay. Let's get started about the objective. So how many of you hear my presentation before on JSON? Okay, that's good. Okay, because the first part or the first objective is to introduce about the JSON Seco API. So if you hear my presentation before, you may see about 5 slides from previous presentation. That's used to give you guys a background of what we're going to do or present in the following part of the presentation. So we first with an introduction on the Seco API. Is it my voice okay? I think it's because of the fan. It makes it a little bit difficult to hear. Okay, we talk about the JSON enhancement and also use case, customer use case. How many of you already heard about JSON? Okay, very good. Already using JSON? Okay, half. Are you using in production?
Yes.
Okay, good. Which company are you from?
Shelter Insurance, Missouri.
Okay, I received a PML from you. I remember that some times ago. Good. So the last part is, the last objective is how you can build applications with Db2 and Watson using the JSON features we provide here. Okay. So with that, the agenda is for what's the objective. So the first part is about an introduction about JSON. And the JSON technologies like what Seco API we provide allow you to manipulate your JSON data inside Db2. And we'll talk about the JSON enhancement. And the last part is about how you build a solution using JSON and Watson. And we'll have some real customer use case. How I see from the field, from the customer, how they're using us. So I want to share with you guys, maybe you guys can use in a similar way. And we will conclude this presentation with a summary and Q&A. Okay? So I think almost all the audience know about what's JSON. So JSON stands for the JavaScript Object Notation. So its spec is very simple. You can find it here. It's, as you can see in the example here, basically it's a name value pair or key value pair, depends on what you want to say. So only 6 type of value. You can see like first name, John, is a string type, okay? You have age, 25 is a numeric type. You also have active, like a true or false is a Boolean type. We also have a frequent flyer number, is a load type, is a fourth. And you have last object. Under address, you have state or city, is a last type. And also we have array type. Under phone number, there's a square bracket, this in red color. It means that there's 2 array entry. The first one is a home phone number. The next one is a mobile phone number, okay? So JSON is getting very popular nowadays for 2 simple reasons. The first one is simplicity. You can see it's very simple. A lot of applications, they provide API, allow you to traverse or searching a JSON field. So because of the simplicity, a lot of mobile applications are using it as a transfer format between itself to the backend, on the mobile front end to the backend, or sometimes they're using JSON as a storage format as well. The second reason JSON is so popular because of the schema flexibility. So if imagine you want to add another entry under phone number like emergency number. Okay? So if you want to store this kind of data in a ratio table, every time you want to add a field, basically you need to ask the IT people to alter your table, add a column, or drop a column, or create a table, whatever, something like that. So if you store this data in JSON, so you don't need to do that at all. Okay, so let's look at the JSON searches inside Db2. We'll talk about the Seco API. For accessing the JSON data inside Db2, there's two ways. One way is using the Java API that allow you to access Db2 using the MongoDB syntax. But that part, we are planning to stabilize that, so I will not talk more on that, okay? So the second part we keep enhancing is the Seco API. When I mean the Seco API, it means a bunch of the UDF and the print function, okay? So the most important is these three. The first one is JSON to BSON and BSON to JSON. So as the name implies, they're converting the data from a JSON format, it's not a text format of JSON, into a BSON, which stands for the binary format of JSON. So these two functions, as the name implies, is doing a conversion. So why we need this one? The reason behind that, because we are storing JSON data inside Db2 as a BSON format, okay, in a inline blob column. So we need these two functions. During insert, you need to call this function to convert your text format of JSON into the BSON format. Same for update. For CNET, you need to call the BSON to JSON to convert the internal format into a text format so your application can use. Okay? So as a developer myself, so you will see a lot of this kind of example in this slide. I'm not a marketing people or salesperson. So you will find in my slide a lot of working examples you can cut and paste and try out and test. And at the same time, I'm a developer. I will ask you guys questions and ask for feedback for some future features we're going to implement. So my first question for you guys, do you see a usage or use case for you guys of sending directly a BSON format to Db2? Or you need Db2 to send out a BSON format to your application? Do you see such use case? Jason, you don't see? Not this moment. Okay. Okay, that's good. I mean, it's good to know. Okay, the second important function about is JSON underscore function. I'm going to talk about it in this slide. So itself is a built-in function. What it does that is search a particular field inside your JSON document. When you find it, it converts that field into a SQL type as you specify as the last parameter here. Okay? The table here summarizes the data types we support. I think it's hard to see at the back, but you can always download the presentation from the website. Okay? You can see this example, how we're using this one. So you put down JSON underscore function. The first parameter is the column. The blob column, you're storing the JSON document in a BSON format. The second parameter, we highlight in green color here, is the field we're looking for. So for the JSON notation, we're using the dot notation to looking at field. So it means that under PO, there's a last object called customer. under customer, there's another last object called SCID. Okay? This function asks DB2 to search for this field. If you find it, convert into integer for me. NA means not A away. So if they search for this document for this field, if they find it, they convert into SQL type integer. If they cannot find it, this function return a load value, or this field is not an integer, it's ABC, whatever. This also return a load value for you. Okay? We have enhancement in this function. I will talk about it later on. So the first thing you want to do is that maybe I should create a table. How do you create a table to store the data? So remember, when you create a table, make sure that the data type is a block type. Okay? Have a inline. This is for performance purposes. After that, you may want to create index on that. We allow you to create index. So it's create index. It's the similar things. We're using the JSON underscore var function and put your index on this CID. If you think your searching criteria is always on CID, you should have this index on. Question?
What does the index structure do if it doesn't have a value for the CID?
So the question is that if the index, they don't have a value for that.
Yeah, they don't have that variable, so put a null, I mean, a big null change, or, because like it had, that's a real problem with other types of indexes over, data that's not there in my index value.
So basically, the similar is basically the same as what the other vector index. So if they don't have value, so we follow the rule as the other index doing. Okay? There's nothing special on that. So inside the table, you can see for this particular example, we can see the data is basically a JSON format. It's not you can see with the query bracket, colon, key value pair. Oh, okay, we move on the enhancement now. Okay, the first enhancement is a PDF. Before I start, actually, I should mention earlier. So we support JSON feature, the Seco API in version 11. Are you guys still in version 10? Or you don't know what version you are? Okay, good. You can try it out. Okay, the first enhancement is like this. So before this enhancement is like this. Okay, the first parameter must be a column, the bob column that contains the JSON document. Okay, with these enhancements, the first parameter will support any expression that return a block value. Of course, that block value must be represent a JSON document. So with that, we open up a lot you can do on these functions. So this, some of them, I will go through some example in detail. Okay, you can use a case expression. So for example, select JSON underscore var. Use a case statement here. When the ID is less one, we're using this one, else we call the other function. Another example, you can create a view on top of this base table. So you can create views, v1, vc1, and select from this table. And then you can using the view column directly as a first parameter. You can use with the table expression with Boolean OR. So you select from a Boolean OR here. So the txc1 is the column from the results from Boolean OR. You can using this one as a first parameter here. Okay, you can using it is the trigger transition variable. You guys using trigger? Using trigger a little bit. Okay, good. So this a transition called N. Okay, so and you can see it's on the PO1. This is a table. Data is the column you store the JSON document. So you can pass this one directly into the first parameter as JSON underscore var table here. So in this example, they're looking for the date, if the date is about 1 year later or the days before today. So they will signal a special SQL state or message here. Okay. Yes, question?
So is there some strategy you can use if you know certain combinations are more likely to do what you query on when you have choice over making the JSON document shape with them earlier in the document maybe to get like, is there any way you can structure your JSON document to make it more more accessible for queries if you know certain key value pairs are more likely to be chosen in your queries?
Okay, the question is it any way can tell, is it any field you will search on more
Let's say
often?
you know you're more likely to look for certain key value pairs. in
Okay.
your JSON document. Can you structure if you have choice over how the JSON document is structured, can you choose to specify, like, should I maybe split first in the JSON document to make it easier for them to be searched on, or anything? Is there anything you can do to tune your JSON document?
Okay, so the question, correct me if I'm wrong. Okay, the question is there any ways that you can tune your JSON document, put certain field earlier, later, to make the search perform better? Is it your question? Okay, so I think the best way is that if you know certain field you always search on, put in the top part, okay, top part of your JSON document. Because for our searching, you know we have a inline part, right? So create index only on the inline part. So put the field you always search on the first part of your document. That will always perform better, okay? So very good question, thank you. Okay, so in addition to the function I just mentioned, I'm going to tell you some other UDFs that's also very useful. Okay? So am I doing okay? Are you guys still with me? Okay, good. So the first one is JSON underscore length. So it is tell you the number of array element. So do you expect, the second question I want to ask, do you expect your JSON data have a weight, like have a weight entry? For example, a purchase order. I have an example here. Okay, for a purchase order, okay? So under items, they may have more than one entry, right? So we put this one around the square bracket, this called array entry. So my question for you guys is, do you expect your JSON document have array? Or you don't know at this moment? Yeah, this can tell me what's the future direction. Should I enhance more on the array or not? So it seems that you guys probably don't know or unclear at this moment.
You mean array elements in your JSON?
Yes.
Well, I think the big drawback is the index on array that LUW has, the ZOS can't do.
Okay, so are you using array?
Yeah, they're using lots of arrays.
Okay, good. Okay, great. This is reason because I asked.
Space business is going to be many arrays, like risk items and
Okay.
drivers and people
I see.
and indexing those.
Okay, so Jason just mentioned they're using array in general. So they can tell me in the future we should enhance more on array. Okay. So this one,
DB2 family compatibility is very important.
I'm sorry, can you say again?
DB2 family compatibility is very important. So anything that's on LUW will work on Z and vice versa.
Yes, I think Dave have a very good comment on basically the family compatibility is important. I think we are always try to make us compatible to the other side family. It's always our long-term goal for doing that. Very good comment on that. Okay, so basically it tells you how many number of array entry here. So look at this example. So we have a purchase order, have the whatever usual things for a purchase order. So they have the items. Under items, the item is individual array entry. So this one will take two parameters. The first one is the JSON, and the field you're looking for, and return an integer here. So for this example, okay, so we select JSON underscore length. Data is the column that store your JSON document, and put down PO items here. So it's pointing at this field. So what should be the result? 2, yeah. It's 2 because there's 2 entry here, right? So if in case you're pointing to a field is not an array, this function return a load value for you. Okay, JSON underscore type by itself is not very interesting, but it's very important for the the next line I'm going to talk about. So I put it here. So basically, they tell you what's the type of the field looking for. So let's look at some example here. How about this one? PO items product name. This guy. So what you think the result for this one? So this is the output, supposed to be 1, 2, 3, 4, 5, whatever. For this guy is a string type, right? So the result will be a 2 here, right? About this one. PO items US pies. This guy. So it should be something like that. So which type? Anyone have a guess? Number 1, very good. Okay. So it's very straightforward, right? So let's look at this one. JSON underscore table. Are you using this function at all? No.
Go back one slide. The 64 bits floating point, that do a big decimal.
I'm sorry, say again?
Can you put a big decimal in that, and that's compatible?
Yes. The question, can you put a big decimal there and be compatible? Yes. Okay, the next function is very useful, so I will explain why it's very useful and important as well. Are you guys using XML? Okay, so are you familiar with the XML table function? XML table function. This function is doing similar thing for XML table function, but it's not as powerful as XML table function. I will explain in a minute why it's like that. So this function takes the same parameter as the JSON underscore function and return a table. The table have 2 columns. Okay, type is the one we mentioned in the previous slide. Okay, and we do have value. Look at the same example, the purchase order. Okay, so look at this syntax. So this function allows you to return the await element. Select X. X is the output from this function, from this table function. Dot star, it means everything from this output. From the table, JSON, PO, and comma and table. We are not doing a join, okay? The syntax wise like this. If you're familiar with XML table function, the same thing. And then you put in this one. The data is the column, and look at this field, okay? So looking at product name. So what will be returned? Very good. So it return a table, okay? How many row? 2 row. Okay, how many column? 2 column. It's like this. Okay? Are you guys okay? Or you get lost? Okay? Because we are building up our example based on this kind of thing. We explain step by step very slowly, okay? The next one, the same thing. We're looking for this item. So the results, the same thing, is a table with 2 columns and 2 rows, okay? Each of this one is an await entry. Okay? So far, so good? Okay, the next one. Getting more complicated now. Log. So the powerful way is that you can using this function, these 2 functions, to convert the JSON data to a relational format. So how you can do that? Look at this one. Wow. So complicated. Okay, let's break it down, okay? Don't worry about it. Let's break it down. Look at this part. The one inside the blue box, okay? This one is exactly what we have done in the previous slide. They return a table with 2 columns and 2 rows. Okay, each row is the await entry. Okay, like this. Right? There's another column called type. It's not very interesting here, okay? So we first go to here. We pass value. This is the output, it's called x. X dot value we pass here. So it means that we first apply the select clause on the first row here. Okay? We're looking for a part number here. In the first row, it's here. And then you output as a column name called add part number. And then you apply the second select clause on the same first row, looking for product name. So basically, you apply all the select clause on the first row, and you finish, you go to the next rows and do the same thing. So the results will be like this. You see? You are converting a JSON document to a racial table format. For the field is missing, for example here, the ship date, this one return a load value for you. Is it wonderful? People like this kind of function because they're more familiar with a rational things, right? When you can create these ones in a rational format, they can do their regular thing like this example here. Of course, this one requires the enhancement we talk about because this field is not a column anymore. It's expression now. So for the people who is not familiar with JSON, what you can do, you can create a view on the top of the original output we have in the previous slide. So this is syntax. So in your item view, basically it's like this. So for the other people, they just business as usual. They just select from this view directly. Okay? So in fact, you don't need to actually store the JSON document as it is inside Db2. You can create a table, a rational column like this, the part number, quantities, price, whatever. With this JSON document, you just do an insert while you're sharing the data. And after this SQL statement, you inside T1, you see this kind of thing. So what we are doing is that you are sharing the data and insert into a table right away. You don't need to insert or store the JSON data as the whole JSON document. Okay? So far, so good? Okay, are you still with me or you are getting lost? If you're getting lost, don't worry about that. You can talk me offline on that. Okay, talk about enhancements on this or something we step into the customer use case. So what happens is that this customer, I should not say customer, okay, I see some use case. They are storing the JSON documents in a varchar column. This happens probably before maybe version 10 or version 9. We don't have the JSON support yet. So they have no choice, right? They don't know what is JSON to BSON, what this kind of thing. So what they do is that a natural way is that they store the JSON document in a varchar column, like this. So to create a table, and then they have a column called data, it's varchar. Okay, now we have JSON features, so they can using our JSON feature. How are they doing that? They call, for example, they're looking for a field called CID. They can pass this column, okay, data, convert it to a BSON format first, and then using the JSON underscore var function, and looking for a field called CID. So the answer is CID here, okay? So the next thing come to their mind is that, how about we create index on it? We can using JSON index. How you can do that like this? Okay, so they create index on this table. We call this JSON underscore var function, put in JSON to BSON, and looking for this guy. Do you think it works? It does not work. The reason behind that, because for all this index, okay, we cannot using UDF. This guy is a UDF. This one is not specific for JSON, it's a general rule for Db2. You cannot create index and your index definition contain a UDF. Okay, our first enhancement is similar to this kind of usage. So they store JSON data in a varchar column. So they're using something like this. For example, they want to find all the name with an age greater than 20. Okay, so they have this is a varchar column. They have no choice. They need to convert your JSON, and then before they call the JSON underscore function. But this guy, this UDF JSON JSON, is producing a logged value. So if they have a lot of this curve, in your table, there's tons or millions of rows, and each JSON document is large, it will easily get into your MyStyle 4 because it hits the limitation of the lot storage. So to address this one, we have a PDF, so we can recognize this kind of pattern, okay? And then after the JSON underscore var finish, we will release or feed the storage. So it will not accumulate the storage from row to row, okay? In order to take advantage of this one, you need to do a rebind, because there's some byte time change on this, so we rebind. Okay, any questions so far before I move to the use case? Okay, let's keep going. Okay, so the first use case is allow Db2 as a REST service consumer. So since we delivered the Db2 latest REST service end of last year, any guy heard about the latest REST service that Db2 provide? Okay, so it's still new. Okay, anyway, that will instead allow Db2 to act as a REST service provider. And what I'm trying to say is that here you can using Db2 as a REST service consumer. Okay, so with both service, basically you have a big picture. You can do it as a provider and consumer. So we have Db2 here. So we have a bunch of other remote servers that can provide service for us. So you can call a UDF, call HTTP GET crop. This is not new for Db2. It's been there since version 10. Okay, the results will come back in the JSON. So with the results come in JSON and with the Db2 JSON functions, now you can use this data now. So how you use it? Let's look at one example here. So first, for example, we send a request to GeoNames to looking for the information about US, okay? This function takes two parameters, the HTTP GET crop. The first parameter is the service URL. The second parameter is an optional parameter. It allows you to put down the header that's required for the other field. So in most example here, this field is node. You don't need to pass in. But later on, when we talk about Watson, you need this part. So basically, they send a request to GeoNames. The results, something like this. It comes out as JSON. They have a status, all this message and value. So imagine you want to extract 10 from this JSON output. How you can do that? So very simple, straightforward. We're using a technique called inline table, or CTE, Common Table Expression. You guys heard about that one? Okay, it's very handy. So I'll show you in a minute how you can do it. So we create an inline table called table A, okay, with this kind of syntax. So this part is same as what we have here, okay? And this part, we capture the JSON output called data in a inline table called table A, okay? And then we pass these results into our JSON to BSON. This guy, we pass to JSON to BSON, and then you extract status.value, status.value. And you cast this one as a integer type from table A, table A. So the answer is 10, right? It's straightforward here. Okay, the other example, you can using a similar technique to send a request to Yahoo to ask for a weather forecast. So before that, of course, you may want to open a web browser to put your URL there to make sure that it returns something, right? So make sure that part works first. So the same thing, using inline table, using HTTP GET crop, The first parameter is surface URL, okay? This is sending a request to Yahoo to ask for a weather forecast for my hometown. It's Fremont, California. So from a web browser, I know it's an array. So this is array object. So for array object, remember to extract the field from array using JSON_table function. Okay, so we put the output as data, okay, and then we pass the output into a JSON table format and extract this kind of field like dates, temperature, whatever you want. So the output is like this. Is it nice? Okay, so these two examples, basically one showing you how you extract a certain field. This example, how you extract something in an array format. So next is the actual customer use case. This use case is from one of the biggest retailer company in US. So what they do is that they do an inventory control. So from time to time, they need to send a request to all these different branch office and ask how many inventory they have, okay? Say, for example, is it item A has more in this location, maybe one of item A in this location, they can move the item around in general. So when I first heard about this one, so I tell them this is what you can do. And then since then, there's so many customers come to me, they say, oh, I want to do something similar. So I think it's a good thing to share with you guys. Maybe you see a similar use case as well on your side. So this is what the architecture here. So they send a request to all these different locations, branch office, okay? The results is a JSON document. Of course, this is a simplified version, okay? So they may have a location, date, inventory, is a weight of different type ID, each different items, and how many they have. So they may have a lot here, it depends on that location. So how they can do it in a single SQL statement, okay? I emphasize a single SQL statement that can fit in the slide. And you can see the slide or the SQL statement at the back of the room. So you can see it's not a fun pin. Okay, this is what they do, okay? So they send a request, okay, to a remote server, the similar technique, okay? Inline table, send a request to the remote office, okay? Whatever comes back as a data, we pass this one into a table function to extract the items and the quantity here, okay? So this is what they have for this output, for this particular JSON document. It will be a table with 2 columns and 2 entries here, item ID and the quantity here. So at this point, if I want to know what does la mean, what you can do, okay? This is how Db2 comes in the picture now. So how you can do that? You have to join. Suppose we have a table inside Db2 already store the description of this part number. So now you can join with the results that you send back from the remote office. How you can do that? In order to find out what's the description of item ID 999 that's coming from the results from the remote office. So this is how Db2 comes in the picture because we are joining data inside Db2. If you're not doing this join, Db2 does not get into this picture at all. Okay, so how you can do that? Okay, the first part is the same as what we have seen in the previous slide. You send a request, and then the result comes as data, and then you pass this data into table function, get these 2 fields, and we put these results in a table called breakdown table, okay? Breakdown table. And so it means that under breakdown table is what we see here. This is what we see in the previous slide, okay? My example is always one step, one step, one step. You know? So after you get this result in your breakdown table, okay, here, you join with the item table. Item table is the table that already exists in Db2. using the join predicate, using the ID as a join predicate. And you find out the ID, quantities, and description. Okay, if you want to think about it in a picture, how you can do that. So this guy, the item table, is already in DB2. Okay, we have description and also the part number. This guy is from the remote office, the bench office. Okay, this is what we get it from the HP get crop. So the final result is that you won't have something like a join between these two. This is the final result. Of course, this is a very, very simple example. So the takeaways or the message I want to send over here is that you can using the JSON feature inside DB2 allow you to join the data from remote sites with the other object inside DB2. Okay, questions?
Yeah, I have a question about error processing in the previous example. What happens if the website's unavailable, for example?
Okay,
Or you don't have web access?
okay, the question is that the error processing, if the website you're talking to is down or something like that. So this function will return a SQL code. In general, basically, this guy, the HTTP get cop, they return is negative SQL code. So this is business as usual as what you see for a SQL statement like this. Yes, question?
If your other description was also in a JSON document, it was also out there or whatever, you can join this, like, can you join to remote?
So your question, if you're inside DB2, you have a JSON document store already. Is it your question? And can you join with the remote one?
Can you join to JSON documents by translating both these tables? Like if you were saying, oh, my row is ID and in a
Right.
right?
Yes.
But what if it wasn't in a DB2 table, it was a JSON document or something?
Okay, so you're saying that if the item table is in JSON format.
Exactly.
Okay, yes. Actually, if you're saying that you want to combine two JSON documents, there's no way you can do that, even for XML. But you can always do a join between certain field, between this one and this one. You can always doing that. For example, you have a JSON document saying, like what you say, right? Maybe part 888 and descriptions, normal, something like that. You can doing that. Basically, you can using this one, you can using a JSON underscore while function. Okay, not here. To extract that fields and using that field as a job case, and then in your Synapse course, you can using the same techniques using JSON underscore var to extract the qualifying row, the field in the qualifying row. Yes, yes, exactly. So the answer is that this does not need to be a relational column. It can be a JSON document as well. So you can do the join between these results from the outside. Okay, Watson. So you guys heard about Watson, right? Okay, if you don't heard about Watson, we must have done a very bad job in marketing. So Watson provides a lot of features, right? We are not talking about all these features. We are going to talk about one particular features. So some features about Watson is that they provide access API, a cognitive API, allow you to do some, for example, speech to text or text to speech, visual organization, all this kind of thing. Okay, this table summarizes some of the API they provide. And the message I want to deliver is that you see in this line, we see a lot of JSON's input or output here. Okay, look at this line. The other, imagine how many JSON you see here. So you can see, with the JSON feature inside DB2, you can link up DB2 with Watson now. And the example I will use is the tuning analyzer. You guys heard about the tuning analyzer? Okay, some of you heard about that. So what that is, does basically they can detect from some text about what tune it is. Is it angry, happy, or some social tendency? Are they open? Are they shy? Or something like that? So let's see how it works, okay? So before that, let's look at the architecture for this use case. So we have DB2 here. We send request to Watson. We call the tune analyzer here. The result is a JSON document, okay? So we come back to DB2. So with this JSON document and JSON feature inside DB2, you can use this output now. So the outputs from the tune analyzer, I think it's very difficult to see at the back about these 3 categories. So, but you can always download the presentation. So it's in 3 categories: emotion category, emotion. It means that are they happy, unhappy, something like that. And also the writing style, are they confident or analytic? Or the social tendency, about are they shy or they want to with other people, something like that. So imagine, right, maybe in your resume or whatever, when looking for a job, they just send it over to analyzer and then tell you, oh, this person is confident. We should hire this person. Or this person is too shy, whatever. Maybe it's not a good fit for this position. Okay, let's see. Let's go for some simple examples to wake you up. So what tune is it? This guy. This is simple for it, okay? I'm so happy today. Of course, happy, right? How about this one? Okay. You can tell it's a like unhappy tune, right? So how about this one, the last one? I'll let you with that. So what do you think about this one? So you don't know, right? You don't know. So the message I want to deliver is that, okay, if a long text or the millions of these cups small text, it's no way you can eyeball the message and tell happy, unhappy, whatever, something like that. You need something like a machine, whatever. Actually, we have another session, a web session, is on building a social media collective using Watson's. But unfortunately, that's not up to be a regular session. In that session, we will showcase a demo of how you can do that. We're getting the data from social media and send over to Watson and bring the data back to DB2 and join with a Db2 table and send a message to some agents or whatever, do some action. So it's a very, very good use case. So maybe in the future, we can make it as an article or something that you guys can have a look at that. So let's see how we can do this, okay? In a single SQL statement, okay? Single SQL statement without any fine pins. Okay, so a little bit about the prerequisite on that. So in order to run this SQL statement, you need to create an account in Boomix for Watson. So at the time I tried, is sometime last year, you can create an account free of charge for 3 months, okay? And then after that, you need to pay, depends on your usage or your contract. I think the rules should be similar at this moment, but it may change, okay? No guarantee. So you need to create a user ID and password. The reason behind that, because for access this service, they require user ID and password. So we're using the same techniques as the inline table. Okay, so the first thing is that you create a credential inside Watson, and then you're using the basic for encoding of the user ID that you get from Watson and the password. Okay, you get this one, you store this one as authorization identity in a inline table called authorization. Okay, the first part. The second part, you start to send this request to Watson. Okay, we're using HTTP guide conf. You should be familiar with that. The first parameter is the URL for the service. You send this one to Watson, and you put the text. Okay, in the previous line, I want to sleep, whatever, blah, 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 blah. So this is the first parameter. The second parameter is the header. So you put this one, the authorization, user ID, password, as a base 64, under the name called organization, basic, and put the header here. Okay, that's all you need. Look at this SQL statement. It's not even fill out the host 9 without any fine print. Okay, so you will get a JSON document like this. Of course, it's a huge document. Okay, dot, 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 dot. So you can see the result is they have something like anger, disgust, fear, joy, and all with a score, something like that. So this you can see is away. So you can see the square bracket here. This should be my last question for you guys. So if I want to extract data from this array structure, what function should I use? If you are listening, you should know the answer. Yes, the JSON underscore table function, okay? So how you can do it still fit in one slide, okay? Look at that. This is the one. Let me explain a little bit, okay? The first part here is exactly the same as the previous slide, okay? So we just put the results as a tune result in a table called tune table. We pass this result into the web part here, okay? Tune result pass here and pass into the JSON underscore table to extract the score and the tune name. And then we sort by the score. Okay, so about that, I want to sleep, but the crazy speaker keep asking questions. What do you think about? What tune you think about it? Is it angry or fear or frustrated? Any other guess on that? I'm going to show the result from Watson. Okay, let's see the result from Watson. Here. Okay, remember the three categories: emotion, now you're happy, unhappy, writing skill, and the other one is the social tendency, okay? The three categories, right? So this is the one highlight card is the three highest score in this three category. Fear. Is it something like fear? Maybe. And then analytic and also extraversion. I'm not sure you agree on that, but this is what Watson tell me about that message, the text that this is what they tell us. Okay? Are you excited with that? Okay. Okay, so except JSON property, you guys want to try out, you can try this one, version 11. Okay. For the SQL support, you need two pieces. One is the Db2 API. There's two parts, pre-conditioning and enable API. Of course, I would recommend you guys to download all the enhancements we mentioned today. The UDF is in a service suite. So as long as you have IBM ID, you can order free of charge. So using this one is having no extra cost to Db2, okay? You don't need to download something. Of course, part of the installation, you download UDF, but you don't need to download with cost, okay? You can just using it now. Okay, this is summary. So we talk about Db2 and JSON, and also the Seco API. Yes, question?
Yeah, I'm sorry. The previous slide is this the same for Db2 12?
Yes, but okay. So the question is that is the same prerequisite for version 12. Okay, so version 12, the service suite is different number. I forget what exactly. It's 4.1. I think it's something like 4.1. But for that one, they already have the pre-conditioning and the waypoint. Okay, so it's already there. So the extra things there for version 12, you have to download the appropriate accessories for version 12. Okay, if you are interested in today's topic, you can read this kind of article written by myself. I mentioned earlier, I like to do research in my spare time. So I like to document my research on all these articles. So in case you cannot sleep at night. Okay, have a read of any of this one. I'm quite sure that you will fall asleep in less than 5 minutes. This is what I ask my daughter to do whenever he cannot sleep. Okay, any questions? No questions. Yes.
Is part of JSON to do more complex double byte characters like /u or something? There's some syntax in there for that.
So is there any special syntax for doing double byte character? So the support on JSON.
UTF-8, like,
Yes, this is my answer. We always handle it as UTF-8. This is part of the standard. Okay.
So when they escape those, can you search on those criteria? Like if the document has // or whatever to do like a UTF-8 character, can you search criteria also specify that as well to look for it?
Okay, the question is that if inside the document they have the double byte character or something like that, so can we search according to that? The question is yes, we can.
And does anyone ever try to put binary data into their JSON document? Do you do base 64 or do you natively kind of understand like?
I left the question is that is there anyone putting a binary data inside a JSON document? Honestly speaking, I never see a use case for doing that. I mean, I don't know the answer, but I don't see any use case. I think that one of the reasons they're using JSON is simplicity, right? They may not want to do it so complicated and causing extra cost to find out the data. So this is, yes.
Typically when people do that with JSON, I think they use like base 64
Yes.
to convert their binary data into the characters.
Right.
But I guess if you don't have syntax, you can't in your query say, by the way, this string is actually binary, give me back binary.
Right, yes. We are doing the string, I mean, it's byte by byte matching as what the regular database searching. Okay, there's no more question. I have one more question for you guys. So what you think we're missing in terms of JSON, or what you want to see if we have bandwidth to deliver what you want, or what you want to see? Dave?
I can see this being a big performance problem.
Okay, performance, okay.
And just indexing and optimization.
Okay, index and optimization. Thank you very much. So, and
Family compatibility is
family capability. Okay, good.
Could you learn statements that are run to actually like build indexes as you see typical queries done against those JSON documents? Can you build indexes dynamically to actually handle them? Like once you see patterns of use, can you actually store, like do you cache the results of those queries and that sort of thing on the JSON documents?
Let me repeat your question. Maybe I cannot get it. So are you saying that is it something like building a dynamic index on JSON?
Or do you remember a result, like past results and start ordering? Like do you or do you even sub-index, like under the covers, or you actually indexing some of those fields for yourself?
It's like something like how to advise which field we should index on? Is something like that? I don't know actually.
And building it, perhaps building it, or anything, or even when people use certain fields a lot, can you build indexes on them and that sort of thing?
I think the part is similar to what we have for the index advisor, but it's not specific for JSON though. So it may need extra techniques for doing that. I mean, maybe there's something we need to do to recognize which field we should put an index on. You have a question, Jean?
I was going to comment, thinking of implementing it, I would think the authorization issues might be important as well, sort of following Dave's suggestion about performance.
Okay, authorization.
Well, for example, if you're using a REST interface and trying to retrieve JSON from somewhere as a practical consideration, you mentioned user ID and password, but you're going to have to ensure that the customer,
Okay.
the user is authorized to do whatever it is they're doing.
I see. So Jim have a comment on the authorization. So that part is not really fall in the JSON part. That part is fall into the HTTP GET COP. I mean that function we send a request to remote server. Yeah, that function allows you to send out the user name and password, and also the header field allows you to specify what kind of authorization you want. The example here is a basic. You can do other things, but you put in your header, and then tell them what method of authorization you want to use. Okay. Any more questions? If not, thank you for coming. Listen to me. Thank you very much.
Thank you, Jane.
Thank you.
This is session F15. Please give me your evaluation.